So under this recording, we'll be doing integration questions, right? So I'm gonna start with and we're also going to be doing differentiation. So we'll be doing two things because we're preparing for test 4. We'll also do differentiation questions. So the first one that we're having is this one, y cube 18xy. So this one, you're gonna, the first step is to introduce d over dx on the left and also on the right. That's the first step. Then now you distribute d over dx, y cube. Then we'll have 18 d over dx of xy, right? Then this one will just give us 3x squared. This one will give us 3y dy over dx. Then this part here will give us 18, and then we'll use product rule in order to differentiate this because we've got x and y. So we're gonna let's start with x. Differentiate x will get 1, then times y plus, and then we keep x. We differentiate y with respect to x. We'll have dy over dx. Then this will be 18y plus 18x dy over dx. 3x squared plus 3y dy over dx. So the question just wanted us to find dy over dx. So that's the first derivative. So now from here, from this step, what we're going to do, you'll take the ones that have got dy over dx to the left, you group them, right? Then you'll have 18y minus 3x squared. Then from here, we'll have dy over dx into 3y minus 18x, and you'll have 18y minus 3x squared. And then we divide both sides by what? 3x squared, divide by 3y minus 18x. So this will be our answer. So this will be our final answer. Usually this has got 5 marks, right? Then we go to the next one. Okay, it means when I add a page, I'll have to I'll have to increase this as well. Okay, it's fine, I'll increase it. Then we'll go to number 2. Okay, the second question is when you've got x plus tan of xy, you're having this equal to 2. And then you'll have d over dx of x plus tan of xy is equal to 2. And then you'll have to also introduce d over dx on the right. Then you'll have y 1 plus. Then the derivative of this one will just be tan squared of xy multiplied by you also have to differentiate the inside. And here we're not gonna have tan squared. We'll have sec squared xy. And now the derivative of xy. So what we are using here is what we call chain rule. We're applying what we call chain rule. Then from here, what we're going to have on the right will just be 0. Let me just increase this template. Yeah. So we're having this, and then now we'll just do what? We're having 1 plus x squared of xy. So the derivative of this one, we already know from that previous question, the derivative of xy, this was the answer, that one. So let me just copy it there. And just copy it and put it down there. So this is our answer for the derivative of xy. So for the derivative of xy, this is the answer using what? Product rule. So we're using product rule here. So this is going to be equal to 0, right? And then from here, you know that we're going to say 1 plus y having z squared xy into y plus x dy over dx equal to 0. So we'll just multiply z squared xy and distribute it. So we'll have this equal to 0. And then what you'll do, you'll take the ones that do not have the y over the x to the right. This will be equal to negative y x squared xy minus y. Then I divide both sides by x squared xy. Divide both sides by x squared xy. Then this two will cancel. Then dy over dx will be negative y x squared xy minus 1 over x squared xy. So this will be our final answer. Then let's move to logarithmic differentiation. And the first one is when you are having y equal to x sine x all over the root of sec x. So here, the first step when you're using logarithmic differentiation is to introduce lim both sides, then introduce it on the right. Then the next step here is to apply the logarithmic laws. So here the law that will apply is that we know for the ln of a over b, this will be equal to the ln of a minus the ln of b. That's what we'll use. Then we just have the ln of x sine of x minus the ln the root of sec x. Then this will be ln of x sine x minus 1 over 2 ln of sec x. Here we're dropping down the constant. I'm using the rule that when for the ln of a to exponent n, this will be n ln a. Right, and then let me also increase this, the next page. Of the next page. So we're having this, and here we have ln of y. So from here, we can just do what? We can just introduce the derivative. So d over dx of ln y, we'll also introduce it here. The ln of x sine of x minus 1 over 2, the ln of sec x. And this will give us what? 1 over y times dy over dx being equal to the derivative of this one will give us a we have to differentiate ln of x sine x. So that means we'll have 1 over x sine x multiplied by the derivative of x sine x minus 1 over 2, 1 over sec x, the derivative of sec x. Then now we're going to have dy over dx times 1 over y, then 1 over x sine x. The derivative of this one will give us x cosine x will apply product rule plus sine of x times 1, right? So we don't have to write that one. Minus 1 over 2, 1 over sec x. The derivative of sec x is sec x tan of x. So that you already know. Then now we'll have dy over dx over y being equal to, so let's just put everything on the right property, and then we're going to have x sine x minus, we have sec x tan x over sec x, then we have 1 over 2, sec x will cancel with sec x, and then we'll have x cosine x plus sine x all over x sine of x minus 1 over 2 tan x. Then I multiply both sides by y. I multiply by y even there. If I multiply by y there, obviously the y's will cancel out. The left the y over dx, which is what I was looking for. And here we'll be having that y. Then we'll have our final answer as, so the value of y is the original coefficient, right? X sine x, this one. So we'll just replace it there, and there is a mark for replacing that. So let me just replace it. X sine x over as the root of sec x, the root of sec x. And then all of this into what? Into x cosine x plus sine of x all over x sine x minus 1 over 2 tan of x. Then here I'm having dy over dx. Right. So we have everything there. And now we move to integration by substitution. Use substitution. So the first one that we are having was this one, the integral of 2x minus 3 over the root of x squared minus 3x minus 1 dx. So what you'll do here, you will say, let u be equal to x squared minus 3x minus 1. Then you differentiate this, you'll get 2x minus 3. Then dx is equal to du over 2x minus 3. Then let's add the new page. Then we're here, right? So now we can replace dx. So we're having the integral. So I'll just say from, that the logic can make sense, from 2x minus 3 all over the root of x squared minus 3x minus 1 dx. This will be equal to the integral of 2x minus 3 all over the root of u. We said it's u multiplied by the u over 2x minus 3. So this one is our dx. So if you check these two, they will cancel, and then we'll be left with the integral of u to exponent negative half du. Then this is equal to, so the integral of this, you just apply the rule that when you have got x exponent n dx, you'll have n plus 1 plus c. So that's what you will do. Then you get 1 over 2. Oh, and then over n plus 1 here. And then here it means you'll have 1 over 2 plus c. Then this will give us 2u half plus c. Then you replace our value of u with what we said u was, and then this was our u, x squared minus 3x minus 1 squared minus 3x minus 1 to exponent half plus c. Then you know that this will be 2 the root of what, x squared minus 3x minus 1 plus c. So that's our answer, final answer, right? Then we move to the next question. We're having the integral of cosine x over 1 plus sine x all squared dx. Then this one, let's add a new page. So with this one, you are going to start by saying, we're going to let our u be whatever is inside this bracket. Then the u over the x will be equal to negative cosine x. Then the x will be equal to the u over negative cosine x. And then from there, you'll just say from the integral of cosine x over 1 plus sine x all squared dx. This will be equal to the integral of cosine x 1 plus sine x squared du over negative cosine x. Cosine x will cancel with cosine x. You are left with negative the integral of 1 over u squared du. Remember we said this one is our u. So now we'll have negative the integral of u to exponent negative 2 du. And if you integrate this one, you'll simply get negative u to exponent negative 1 plus c. So the negatives will cancel, and then you'll be left with u to exponent negative 1 plus c, which is equal to 1 over u plus c. And our u, we said it's 1 plus sine x. We said our u is 1 plus sine x plus c, and then you get your final answer. Then we go to integration by parts. Let me change the color of this pen. We'll go to integration by parts. Questions, right? Then we're having number 1, the integral of x squared sine of 5x dx. So I said you're gonna use this formula. The integral of u dv will be uv minus the integral of v du. And then what I said is that you're gonna use the abbreviation Liat. And I said it's for logarithmic functions. Let me write it here. Said it's for logarithmic functions. I said it's for inverse functions. I said this for algebra. T is for trigonometric functions, and then E is for exponential functions. So I said you use this abbreviation, you know that the one that starts first on your equation will be your u. If the logarithmic is starting before the algebra, then the logarithmic one will be your u. So in this case, we've got an algebra and we've got an trigonometric function. So A starts before t. So our u, we're going to say let u be equal to the algebraic one, x squared. And then since we want the u, we're going to say the u over the x, which will be 2x. And then from here, it means we'll say the u is equal to 2x times dx. Then we're done with that part. Then our u is this one. That means our dv will be the remaining part. So we have our dv as sine of 5x dx. And then you integrate both sides. We'll have v. The integral of dv, just know that it is v. And then the integral of this one, it will be 1 over 5, the cosine of 5x, and it will be negative plus c. So now you have your v, you have your u, right, and you have your du. So now you just substitute everything. So from the original question, x squared sine of 5x dx. Remember that you must have uv minus the integral of v du. I'm just reminding you, right? Then your u is what? Our u is x squared. And then my v is the one that I got there, 21 over 5 cosine of 5x minus the integral of negative 1 over 5. Let me just put this here. Let's move this. Then we know that here we're having negative 5, negative 1 over 5, the cosine of 5x. And what else are we having? Then we have got the u. We must, and then we replace the u, which was 2x dx. X squared sine 5x dx. So we know that this will be negative 1 over 5 x squared cosine 5x minus, and then the minus and this minus, they will cancel. They will give us positive, right? Now we'll be left with the integral of 1 over 5 cosine 5x 2x dx. So which means now we'll have to do what? In order for us to integrate this one, we'll have to use integral by parts again. So let me just wrap it up by saying I want to put the constant 1 over 5 out there. So I'm going to have 1 over 5 will come there. Then the integral cosine 5x 2x dx. So I must get the answer of this. So I'll solve that on the next page. So the integral of cosine of 5x 2x dx. So I'm gonna let my u be equal to, so using the archer, we're gonna say the algebraic one is our u will be 2x. The u over the dx will be 2, then the u will be equal to 2 dx. Now I have my du, I have my u, then the v is equal to cosine of 5x dx, and then I integrate both sides. The integral of the v is v. The integral of this one will be positive 1 over 5 the sine of 5x plus c. So now I can substitute. So the integral of this guy of cosine of 5x 2x 2x will be equal to, my u is 2x, v it's 1 over 5 sine of 5x. Then we know we have minus the integral of v. So let me just reduce this to, so the integral of v, we're gonna replace this part with v, which was that, and then the u, the value of the u is 2 dx, and we've got 2 dx. Then this will be equal to 2x over 5, the sine of 5x, minus 2 over 5, the integral of sine 5x dx. Then this will be equal to 2x over 5, the sine of 5x, minus 2 over 5. And then the integral of this one, we know it's going to be what? It's going to be 1 over 5, the cosine. It will be negative 1 over 5, the cosine of 5x. Then plus c. Then let me just wrap this up. We'll have sine of 5x minus, this will become positive due to this negative and that negative, 2 over 25 cosine of 5x plus c. So now we can replace this answer back there and replace it here. So remember, we're looking for the integral of x squared sine of 5x dx, and this will be equal to, I already have everything. Let me just copy this. Right. So now I'll paste everything here. Yeah? So we're having this. Okay. So, and this is equal to what? 1, 2. Let me check by, okay, this is a negative. So we have a negative here, negative 1 over 5. Right. So here the only thing left is for us to replace this one. So we have that, and then cosine of 5x plus 1 over 5. So the integral of this one, we have it is this part. So I'll just copy it as well. Copy, and then let's put it here. That means we'll also have to reduce this one. Okay, we'll just put everything there. here we're having 5x. Then we have a 2. And here we're having plus, this was what? 1/5. Or, yeah, we're having 1/5, multiplying everything there. Yeah, so the only thing left would be to simplify that, no? So let's do that on the next page. So the only thing left is for us to simplify this part. You know that everything here is equal to the integral of integrating which part? Oh, it's equal to the integral of x squared sine 5x dx. So the final answer will just be 1/5x squared cosine of 5x plus 1 over, okay, you are going to multiply there, we'll have 2x over 25, the sine of 5x plus 2 over, and then multiply 25 with 5, we'll get 125 cosine 5x. So this will be our final answer. So the integral of x squared sine 5x dx equal to that. And then we'll move to the next question. The next question we're having number 2, we're having the integral of x dx dx. So here, using the abbreviation DH, our u is going to be what? The exponential is the last one, so obviously our u will be the algebra, which is x. Then the v will simply be ex dx. You integrate both sides, you get your v being ex plus c. Although the u over the x will just be 1, and then the u will be equal to the x. Then you substitute from this formula. You know, when you are having the integral of x ex dx, x v is dx du is equal to dx. We have it there. Then we're gonna have x dx minus dx plus c. So this will be our final answer. Then with trig substitution, yeah, I said we've got what talking about integrals of this form, of the form, the root of a squared plus or minus x squared and the root of x squared plus or minus a squared. So we've got 3 conditions. I'll write them. The first condition is when we are having the integral of a squared minus x squared, we are going to let your x be equal to a sine u. 2, when you have got the integral of a squared plus x squared, you let your x be equal to a tan u. Then the third one, when you have got the integral of x squared minus a squared, you let your x be equal to a sec of u. Now, for an example, right? Let me check for an example on your guide. So let's do an example here. So this one will just be the, I'll do one example for this and maybe try to check for an example on integration by partial, although it won't be part of test 4. Let me just check for examples here. Yeah, let's say you're given the integral of dx all over the square root of 5 minus x squared. This simple one. So if you are given something like this, so root of 5 would be your a. Because if you square it, you'll get 5. So this will be a squared. Then we've got minus x squared. So meaning that we're going to let our x be equal to the root of 5, the sine of u. And then we'll replace where there is x with that. Then we know we have 5 minus, and then x is root of 5 sine u. Then we square this, and this will be the integral of what? The x all over the root of 5 minus 5 sine squared u. And then I can simply say this is equal to the integral of the x over the root. I take out 5, I'll have 1 minus sine squared u. Then this will be equal to the 1 over the root of 5. I can take it out as my constant. 1 over the root of 5. And I'll be left with the integral of 1 I'll write the integral of the x over the root of cosine squared u. Cosine squared u, that's what I'll be having. Then from there, I'm having 1 over the root of 5, the integral of the x. So the answer of this will give me cosine u. Then we know that we'll have to replace the x, right? So from the fact that we say let our x be equal to the root of x, we say the root of 5. The root of 5 sine of u. Then I can come here and say the x over the u will be equal to what? If you differentiate this, you'll get root 5 cosine u. Then the x will be equal to the root of 5 cosine u times the u. Then I'm going to take this and replace it where there is the x. So we know that from the integral of 1 over the root of, no, from the integral of 1 over root 5, the root of 5, the x over cosine u, this will be equivalent to 1 over root 5, the integral of root 5 cosine u du over cosine u. Then this will cancel and these two will cancel. Then I will be left with the integral of the u, which is simply going to be u plus c. And we know our u, we can take from the fact that x is equal to the root of 5, the sine of u. I can divide both sides by root 5 with 5. Then I can make u the subject of the formula. Then my u will just be the arc sine of x over root 5. Another way you can represent, so meaning our final answer will just be arc sine of x over root 5 plus c. Another way you could have done this from the fact that x is equal to the root of 5 and u. So you can be a lot of values. You can say I'm dividing both sides by root 5, then I have sine u being equal to x over root 5, and then you sketch a triangle. You sketch your triangle. So if you sketch your triangle there, you'll have u, then x root 5. This one will be your opposite. This one will be your hypotenuse. Then this part will be, bottom part will be what? Let me copy this, move it. This part will just be 5 minus x squared. So if you want to represent your u in terms of tan, it means tan u will be equal to opposite over adjacent, which will be x over the root of 5 minus x squared, meaning that we could have also said that u will be equal to the arctan of x over the square root of 5 minus x squared. So the final answer could have also been arctan of x over root of 5 minus x squared plus c. Or you can represent everything in terms of cos, which I'm not gonna do. And then under integration by partial fraction. Here we've talked about a lot of rules. So I don't know if I should. Okay, let me try to remind you of those rules before I can do an example. Now I will have to first copy those rules, right? Here are the rules. They are saying that if you have the first one, we can say if you have got the integral of the form, no matter whatever the function is then up there, but most importantly, if your denominator is a linear, consists of linear factors, then you're differentiating, then you're going to separate this to be the integral of a, okay, let's just say, let me remove this for now so that you don't get confused. Let's say you are just having a over x minus a, x minus b. This is our rational function. And then to convert it into partial form, it means you're going to say b over x minus a plus c over x minus b. So let me use this one as a, let me just say this one is px so that I can let you get used to this. You'll separate these things like this and then you're going to solve. So if here you're having the integral x, then this will be equivalent to the integral of this. The integral of that. Then if you are having the integral of px, let's say now you have got that polynomial, the square of a linear function. Then in order to integrate, you'll say the integral of a over x minus a plus b over x minus a all squared. And then you say dx there. The third one, dx, if the linear factors are more than 2, we still separate the same way as number 1, the same as number 1. It will be a over x minus a plus b over x minus b plus c over x minus c, and then dx. 4, if you're having the integral of px, then let's say now you have got that polynomial and you have one linear factor. Then you'll just see this. This is equal to the integral of a over, you can write the linear factor first. It will be what? It will be x minus b, then plus b over x minus a plus c over x minus a all squared. 5. If you're having the integral of dx, let's say now you have this one, x minus a x squared plus dx plus c, quadratic and a linear. So this will be the integral of a over the linear expression, then the x plus, no, we don't have to separate this, just use the brackets, plus bx plus c, and then here you just put the polynomial or the quadratic function, then the x, right? Now, an example will be if you are having, I'll start with the one with the case whereby you have, so there are 4 cases, 4 methods. The first one, it's when you've got a linear factors on the first method. Then the second one, it's when we have the one by the denominator, the degree of the denominator, you find that it's higher than, no, the degree of the what, of the numerator, actually the opposite. Find that the degree of the numerator is greater than the degree of the denominator. But these ones will do them. I'm just reminding you. Then I've got a case whereby I've got repeating vectors. Then the fourth one is when I've got a reducible vectors. So let's just do an example of when you've got what, linear factors. Just simple linear factors. Let's say you are given the integral of 4x squared minus 14x plus 6 all over x plus 1, x minus 3 dx. So here you're going to say this guy, you'll equate him, you'll equate this guy with a over x plus b over x plus 1 plus c over x minus 3. And then you'll multiply on the left with this. Then you multiply. Then these guys, they will cancel out. Then we'll have, then if you multiply by the very same what, you multiply on the right, x minus 3. You multiply everything on the right, which is just a over x plus b over x plus 1 plus c over x minus 3, right? Here we know we will be left on the right, on the left we'll be left with this. Then on the right you'll be left with a into x plus 1, x minus 3 plus b into x minus 3 plus, then you'll have your c. Let me move this to the left. Yeah. Then you'll have what? Plus c into x plus 1. Yeah, you'll be left with something like that. Let's move to the next page. So now you'll be having this. This one we know it's 4 being equal to that minus 3 minus plus 1. Okay, we are having 4x squared minus 14x minus 6a into x plus 1, x minus 3 plus b, x minus 3 plus cx, x plus 1. So what we'll do here, we'll let, in most cases, we'll just let these numbers, numbers between -5 until +5. In most cases, you can just try using this one. You'll be able to get the unknowns, which is a, b, and c. Remember, the aim of doing that is so that we can have something equivalent to this. We want to get these values so that we can take this and replace it there. I hope that's clear. Then let's move. Then what I'll do, I'm gonna let the first part, I'll let my x be equal to -1. So on the left, if I put -1, we'll get 12, and then this will become 0, plus we put -1, we put -1 minus 3, then plus 0, because here we're going to substitute 0 where there is x. C times x, it will be 0. And then we'll be able to calculate b. See, we're left with one variable. Then this will just be -b into -4, 12, and this will be 4b is equal to 12. Therefore, b will be equal to 3. And then now we calculate the value of a and c. So we're gonna do that. So we're gonna say we can now say let x be equal to 3. So we'll put 3. Now we'll put 3. So if we're putting 3 on the left, we're gonna have what? I'm gonna have -12. If I'm substituting 3, I'll have -12 being equal to. So for a, for this part, I'll have 0 plus 0 also for that part, plus c. So this will enable me to calculate the value of c. And this will be 12, 12c, -12. My c will be -1. Then now I will let my x be equal to. Now I have the value of b and c. I want the value of a. I can just say let my x be equal to 0. And then if I put 0 on the left, I'll have -x. So let me change the color here. Okay. If I'm putting 0, I'll have -6 on the left being equal to a into 0 plus 1, 0 minus 3. The rest will be zeros. And then I can say my a into -3 to 6, my a will be +2. So now I can reduce everything. I can write that equation. Let's just copy it. Let's copy this. I'm going to checking the answer. And then let's go back there. Then we're having this. So this will be equivalent to, so this part will be equivalent to the value of a is 2 over x, b we got We got 3. So now we're having 3 over x plus 1 plus c is negative 1 over x minus 3. So now I know that from the integral of 4x squared minus 14x minus 6 all over x plus 1, x minus 3 dx. This can be rewritten as the integral of 2 over x plus 3 over x plus 1 plus negative 1 over x minus 3 dx. And then you integrate, you distribute the integral sign, and you'll have the integral of 2 over x dx plus the integral of 3 over x plus 1 dx plus, and then you'll have negative integral 1 over x minus 3 dx. Then this part will give me what? 2 the ln absolute of x plus 3 the ln absolute of x plus 1 okay, then plus, and then this will be minus, right? Because we have a minus there, minus the ln the absolute of x minus 3 plus c. So this will be your final answer. But this was the first case. So we'll do the second case, third case, and the fourth method. So left with 3 of them. We'll do them. Let me see if we can add something here. So under integration by what? Let's see if I have anything to give you to write here. Yeah, you can just go and practice this one. This one will just be for practice purposes. Because we've already done a lot of things on integration, but you can just go and integrate this one. With x over x squared dx. Integrate this and do this one. The integral of x cubed root of 1 plus x squared dx. Those 3. What else? Okay, so on your scoop, they said they're gonna give you a, they'll want you to integrate functions, of the form e to exponent x and ln of x. So such questions, they're just referring to things like this. Find that you are having, let's say, 3 times x squared dx. So with this one, it means you will say that you'll use this substitution. Let u equal to x cubed plus 1. Then du over dx will just be 3x squared. And then you can say my dx is equal to du over 3x squared. Then you go and replace that with u. Then you have x squared. Dx will be du over 3x squared. Then these two will cancel. And then we'll be left with the integral of e to exponent to du. Then 1 over 3 eu c. That will be our final answer. And then you'll just have to replace the value of u with x cubed plus 1 plus c. And then ln x, when they are talking about these ones, means they can say integrate the ln of x multiplied by, let's say, you see multiplied by what? Multiplied by x dx. So this one you can say let your u be equal to ln of x, and then du over dx will be 1 over x, and then dx will be equal to du, it will be equal to du x. So okay, this one, it means you'll have to use integral by parts. Use substitution is not gonna work here. U x du x. Yeah, this one you'll have to apply integration by parts. So we'll end the session here.